Hi everyone, I'm just going to go through a couple of questions before you guys take your quiz, so make sure you have your calculators out, something to write with, the packet from yesterday, and the purple and blue looking forward. We're going to start a new unit tomorrow, provided we're here. If not, we'll start it on Friday. Okay, so in the purple and blue packet, flip to the second page. So what is a sampling distribution? It's a distribution where each point represents a sample. And then we're looking at how do we use this with means, x bar? So you should be comfortable knowing that, okay, there's three conditions I need to check: random, independence, nearly normal. Generally, we have our samples bigger than 30, or we're told, and then that tells us, okay, we can use the normal distribution with this mean and the standard deviation, you're given that. Now, if I'm going to solve this in a question, in this case, we were told a simple random sample of delinquent accounts were taken. Assume the accounts are independent, since 50 accounts is less than 10% of all accounts. When they're telling you it's a national department store, that's a way of making sure that you know it's a really big department store, so 50 accounts should be less than 10%. 50 is greater than 30, so again, the outstanding bills, how much is due, are approximately normal. We have the mean and standard deviation. You're going to do normal CDF. We're shading above. So 200, infinity, here's our mean, here's our standard deviation, and I believe if you do this in the calculator you get 0.9476. Check me on that, I might be off, pretty sure I rounded, okay? Yeah, that can't be right, actually, I know that can't be right. And then the reason why I know it can't be right is because this is over 200, so go ahead in your calculator, I must have typed something incorrectly. Do over 200 and you should get a lot smaller probability than that. Okay. Then if we have qualitative data, we're talking about proportions, p hat. And you have two options here. You can check your conditions, randomness, independence, and then what we call our success failure. N times p is greater than 10, greater than or equal to 10, n times q is greater than or equal to 10. Then we have the distribution that's approximately normal using this mean and the standard deviation from your formula page. So solving our question this way, told a random sample of households, 60 households is less than 10% of all American homes, so we can assume independence. 26.4% of homes do own a dog, not 26.4%, 26.4 homes own a dog, 33.6 own a dog. Here's our mean, here's our standard deviation. We do shade above 40, and then this would be the value we plug in here. And then you can compute the probability. I think here you get like 0.733 or so. Then if you want to, your other option is convert this to a binomial. So since we're talking about the proportion being greater than 40%, I change that 40% into 40 out of 100 equals x over 60, which is my sample size. I get 24, so I'm looking at greater than 24. So for a binomial, this would be 1 minus being less than or equal to 24. 1 minus binom CDF, and I believe you get 0.68. 78. Okay, so it's your choice in what you do here. For means, you have no choice. For means, you have to check all three conditions and complete the problem this way. For proportions, it's your choice whether you use the normal distribution or you use the binomial. Now from your packet from yesterday, the very last page, I asked you to complete this for homework. We have cereal boxes, how many ounces are in them with the mean and standard deviation. I think there was a hole punch here, but our sample size was 5. Okay, so we're told we randomly selected cereal boxes. We can assume the boxes are independent. We're not talking about people here. And we're told that we have a normal distribution. So it doesn't matter that our sample size is only 5 because we know that it's following a normal model. So then using my formula page, mean and standard deviation, I'm looking at less than or equal to 9.65. So negative infinity, 9.65, our mean, our standard deviation, and this is scientific notation. It's a very small probability. So you can write your answer like that, or you can write it as 0.00000 96995. 96995. I'm going to do dot, dot, dot. Okay, so you can go through this video one more time. Make sure that you're doing everything in context when you're checking your conditions. When using your calculator, be careful with how you type values in. You just saw me make a mistake. Okay, and if you have any questions, I will be in tomorrow. Hopefully I'll see you tomorrow. Good luck on the quiz. Show all your work, even for the multiple choice. There's boxes for you to show work. Good luck.